Hello seniors, I hope you're doing fine today. Today we're going to continue with electronic assignment 12, which is about Pascal's triangle and the binomial expansion. We've already covered the theoretical part of this, and we've also covered the first exercises, which are the simplest ones, okay? So for today, I want to finish with the last two exercises of this assignment and pay close attention to these ones, because these are the ones that, or these types of exercises are the ones that usually appear on an IB exam, and these exercises are the ones that usually students struggle the most, okay? So please pay attention to this. Okay, so let's see the first exercise. It says, find the x cubed term in the expansion of 4x minus 1 to the power of 9. Okay, so there are different ways in which we can solve this, but I'm going to show you the one that I consider the shortest and maybe also the easiest. And okay, but in order to be able to solve it this way, we need to recall this formula that I put here on the left, which is not exactly like that in the formula booklet, but this is the general form in which we can find any term of a binomial expansion, okay? If I go back to the formula booklet just for a second, this is how you see the formula for the binomial theorem in the formula booklet, okay? So you see that it's a plus b to the power of n, and then we have the expansion, a to the power of n times 1, which is the first coefficient in the Pascal's triangle. Then the combinations of n taken 1 each time. Remember that the first term actually this is n0, right? Then n1 here, then n2 here, and so on, okay? And we need to calculate those values using the Pascal's triangle or using the calculator. So remember the exponent of a goes decreasing while the exponent of b goes increasing until b reaches the maximum exponent, which is n, okay? So this is how you see the binomial theorem formula in the formula booklet, but I'm only going to focus on this term over here, which is like the general term for any term you want to find in a binomial expansion, okay? If you really understand what each of these terms imply, then this is easy. Remember, this over here represents the coefficient. Let me write that. I'm going to write that in the electronic assignment better. If we go here, this term over here represents the coefficient in the Pascal's triangle. Coefficient from Pascal's triangle. Then the value of a is the first term. You already know this. A is the first term, which in this case would be 4x, right? And b represents the second term of the binomial expansion, which in this case is -1, okay? And okay, so n is the maximum exponent, which in this case would be 9, and r is a specific position we want to find, okay? So given those pieces of information, we're going to see how to solve this. We want to find the x cubed term, right? So that is a term, when we expand this, the term that contains x cubed, okay? So if I write the general formula, nr of a to the, well, first of all, well, yes, I'm going to write the formula, a to the power of n minus r times b to the power of r. So let's identify our data. Do we have n? Yes, we have n, which is 9. So n equals 9. Then we have a in this case would be 4x, the first term, and b is -1, which is the second term, okay? Then I'm going to rewrite this by saying this is 9r, we still do not know r, times 4x to the power of n minus r times b to the power of r. Okay? So what do we know now? We want to find the x cubed term. So what is the only, sorry, this b is wrong here. It should be times -1 to the power of r. There you go. So if we want the x cubed term, then the only part where we have an x is here, right? So this exponent over here should be equal to 3, right? In order to obtain an x cubed. So we're going to set that to 3 and say that n, remember that the value of n, let me change that. I'm a little bit distracted today. The value of n is already 9, okay? So we know that 9 minus r should be equal to 3. So if we solve for r, we will find the value of r here, and this would be r equals 6. So now we have the value of r, and we can easily solve this. If we rewrite the expression, this would be 9, 6 times 4x to the power of 9 minus 6, which is 3, times -1 to the power of r, which is 6. Okay, so then we can solve this. We can find this term by using the calculator. Remember how to do that? If you go to your calculator, I'm just going to say this, I'm not going to show it because you already know this. You go to option, prob, NCR, and then you put 9C6. And the value you obtain here is 84. So this gives us 84 using GDC. Okay. I'm going to write it another way. I'll write it like this. N6 equals 84 using GDC. So if I continue the exercise up here, then this would be equal to 84, the coefficient, then times 4x cubed times -1 to the power of 6, that's just +1, right? So finally, we need to calculate 4 cubed. 4 cubed is 64, so this is 84 times 64 times x cubed. Finally, if we multiply those terms, 84 times 64, that gives us 5,376 x cubed. So this is the x cubed. Oh. This is the x cubed term of the expansion, okay? And this is our answer. Is it clear? I hope it is clear enough for you. So this is the x cubed term. Then let's go to this exercise, which I consider to be the most difficult. And I'm going to show you how to solve this, first of all, using GDC, in which, in my opinion, for this particular exercise, using GDC makes it a lot harder than without GDC. But I'm going to show you that now. This is a very, very difficult problem. So it says, in the expansion 2x plus 1 to the power of n, so now we're not given the value of n, the coefficient in the x cubed term is 80. The coefficient, that's the number we have in front. In this case, the coefficient of the x cubed term was 5,376. Now it's 80. So find the value of n. Okay, so I'm going to show you how to use a calculator. We know that the x cubed term, if we use this formula over here, we know that for some value nr, some coefficient in the Pascals triangle, times a in this case is 2x to the power of n minus r, I do not know n nor r, times b, which is 1 to the power of r. This should be equal to, if we develop this and we want to find the x cubed term, which which its coefficient is 80, right? So we will set this equal to 80 x cubed, just in order to solve this, okay? So let's see. This 1 to the power of r, we don't care much about this term because 1 to the power of, to any power is always 1, okay? So we can rewrite this as nr times 2x to the power of n minus r equals 80 x cubed. Okay, one thing that we do know is that we want the x to be x cubed, right? So this, once again, n minus r should be equal to 3, right? N minus r should be equal to 3. So here I can, for example, solve for r and say that n minus 3 equals r. But here I'm having two equations with two variables, which are, three variables and two equations, which are n, r, and x, okay? So we still cannot solve this. In order to be able to solve this, I need to apply the concept or the formula to solve combinations, which is the one that we saw during the last class, the one about factorial, right? If I write this expression, but instead of writing r here, I'm going to write its equivalent, which I just found, which is n minus 3 equals r, then I might be able to find the value of n, right? Because we're only going to have one variable, which is n. So let me do that here. So I'm going to be using the second formula, and I'll say that n minus 3 equals n factorial divided by r, which is n minus 3 factorial, times n minus r is 3. So this is times 3 factorial. You see that n minus r, this one, is what we have here. N minus r is 3. So if we solve this, how do we take the factorial of a letter, n in this case? Remember the concept. 4 factorial, for example, is the same as saying 4 times 3 times 2 times 1. The numbers go decreasing, right? The same thing occurs when we have a letter. If we have n factorial, this would be equal to n times n minus 1 times n minus 2 times n minus 3, and so on, okay? The same concept applies. So let me erase this. Or I'll leave the 4 factorial there just for you to remember. So this will be equal to n times n minus 1 times n minus 2 times n minus 3. And this keeps on going. I'm going to write n minus 4 and then the ellipsis and whatever. This keeps on going up until infinity. But you will notice something. Now, if I divide by, I have n minus 3 factorial, so that would be, we will start with n minus 3, then go to n minus 4, then go to n minus 5, and so on. This will keep on decreasing, times 3 factorial, which is 3 times 2 times 1. So you notice what is happening here, right? This n minus 3, n minus 4 up to infinity cancels out with all of this, right? N minus 3, n minus 4. So let me cancel this out, all of this until the very end, all of this until the very end. So we will just be left with, let me do that here, n times n minus 1 times n minus 2 divided by 6. Okay, so this is the result for this combination over here. Okay, now another thing, we already know that n minus r should be equal to 3, right? So if we work with the coefficients, this is a coefficient and this 2 over here will also add up to the coefficient, then we know that nr times 2 cubed, right, should be equal to 80. right? We're only working with the coefficients, 80, 2, and this Pascal's triangle coefficient, okay? So the value of NR, which we found here, times 8 should give us 80, which is the piece of information we were given at the beginning of this exercise. If we divide the 8, we would get that NR should be equal to 10, right? So we will set up this equation over here to 10, and then we will be able to solve this. So let me do that right here. We would say that n times n minus 1, this is a little bit long, times n minus 2 divided by 6 should be equal to 10. And then we need to solve this. If I take the 6 multiplying up, this would be n times n minus 1 times n minus 2, which is equal to 60. And then if I use solver here directly, I will already get the answer, but let's do this. Let's do the distributive first. So I'm gonna distribute this. First, I will do distributive between these two, and we would get n times n squared minus 2n minus n plus 2 equals 60. Finally, if I distribute this n over here, I will get n cubed. If I add these two, this is negative 3n. Negative 3n times n is negative 3n squared plus 2n. And if I take this 60 to the other side, it'll be minus 60 equals 0. So here we get a cubic equation. That's why I told you that you will need a calculator for this one. So if we get a cubic function, the only alternative we have to solve this is by using our calculator. So I'm going to show you how to use a calculator. If you see, okay, this is the calculator. Let me see if I can make this a little bit bigger, large. I'll take this here. Okay, so we go to menu, and then we go to menu equation. This is a case of polynomial, so F2, and then this is degree 3 because it's a cubic function. So click on F2, and then you plug in the coefficients. Yes, the coefficients in our case are 1 for the x cubed, then we have negative 3, then we have 2 positive, and finally d is negative 60. So we click on execute, and there we have the only value, which is 5. So if we go back to the electronic assignment now, we will get the value n equals 5. And the question was find the value of n, so there you have. This is the answer, n equals 5. So this is a tough exercise, people. Make sure that if you have doubts with this one, please ask, and we will try to review this in the live session. Now, if we don't use a calculator, I'm going to show you this, how I would solve this without using a calculator. Okay, let's see if this works out. I need to find the x cubed term, which I know its coefficient is 80. From our expression, I'm going to write it here, 2x plus 1 to the power of n. I know that the only term besides the Pascal's triangle coefficient that will add up to my final coefficient is this 2 over here. This 1 does not add up to the coefficient because 1 to the power of any number is always going to be 1, right? So I thought about the following. I know that there is a value of, or there is a coefficient in the Pascal's triangle, which if I multiply, remember that as I am looking for the x cubed term, to make this x cubed over here, this 2 should also be cubed, right? So I'm going to take this to the third power, and this should equal 80, which is the coefficient we had at the beginning of the problem, okay? So it's basically the same step we did here. So I know that the coefficient in the Pascal's triangle that I'm looking for should equal to, let me solve this. This is 8 equals 80. So if I take the 8 dividing, this is an r equals 10. So the coefficient I'm looking, coefficient in Pascal's triangle. The coefficient I'm looking in the Pascal's triangle is coefficient 10, okay? So I'm gonna quickly build the Pascal's triangle here. 1, 1, 1, 1. We'll see what happens. So this is 2 over here, 3, 3. I need to stop when I get to a 10, okay? So this is 5, 10, 10, 5, 1. So here you see that we get 2 10s, right? This one and this one. Now, if I take a look at this, in which of these 2 10s will I get an x cubed? What do you think? So let's analyze the row of this Pascal's triangle. This is, remember, this is the first row. This is second, third, fourth, and fifth, right? If our expression is like this, then the first term should be x to the power of 5 in this case, right? It'll be something, I'm not looking at the 2 for now, I'm just analyzing the x, okay? So for the first term, this would be x to the power of 5. The second term would have x to the power of 4, and then the third term would be x cubed, right? So this is actually the 10 that I need for my binomial expansion, the one that I'm being asked, okay? So finally, I can already know the value of n, and the value of n would be directly this row over here. Remember, the value of n determines the row in the Pascal's triangle, so the value of n is directly 5, because that's the row where I find the 10 that I need in order to obtain a coefficient of 80 in the x cubed term. Okay, so this is how I solved without using calculator. It's a little bit conceptual, but I hope that it's clear enough for you people. So that's it for today's class. If you have any doubts, please let me know, and we can keep on covering this topic, which is a particularly difficult topic. And we're gonna practice with some real IB exercises for you to really try to understand this. And that's it, seniors, sorry. Hope you have a nice day. See you.